I think on the calendar it was originally Wednesday, but I think I moved it to Thursday for a couple reasons. Number one, we have some AP physics kids with tests on Wednesday and Thursday. And if we had it on Wednesday, maybe not. I don't know. That's what period 1 said. Maybe they're wrong. Because I didn't see it on the calendar. I saw it in like 2 weeks, but I don't know. But if we were having it on Wednesday, it would be kind of crammed in. I don't really want to cram in our first test. So instead of having it Wednesday and we kind of like rush it, I would rather have it Thursday and we spread it out. So our test is going to be next Thursday in class.
When does the first reading period end?
Next Friday? The Friday after? I think it's Friday after. No. So I think in like 2 weeks.
So I need to raise my math.
You have 2 full weeks.
This week, then there's one more.
Yeah. I think you have Monday. Oh, you have 3.
I don't know.
You have 2 or 3.
This is already yeah.
Yeah. So not next week, but the next Friday. Also, did we do anything in... Okay, now that I lost you all. Hold on. Come back. Shush. Okay. So, in this class, coming back, we have a test next Thursday. We have section 1.5 today and section 1.6 probably tomorrow and Monday. We have a practice test. That's going to be a thing. We have AP Classroom. We're going to talk about tomorrow with practice AP multiple choice questions. That's going to be a thing. And then a forever quiz. That's going to be a thing next week. Okay? Okay. But right now our goal is to finish section 1.5 notes, make sure that we're good on the homework for tonight, and then go back and revisit section 1.4 as we grade. We will also go over our flip book and finish another page. So here we go. Ready, set, section 1.5, infinite limits, and I don't think the screen has been unfrozen yet, has it? There we go. Although that would be freezing, not unfreezing. Infinite limits. Infinite limits. What I was saying a second ago is the only way that a limit will equal an infinity as x approaches a constant is if we have this number over infinity that results when we try to plug in. Now, if you notice, I have not put in equals because this is naturally undefined, DNE, right? So I can't put equals. This just points me in the direction of where I need to look. And if you guys remember, we're supposed to be checking the SIGN sign, right? We're supposed to be checking the sign. So, down here, when we're trying to check the sign, wait, this one just says graphically, which means we're supposed to know how to graph this guy? Who knows how to graph this guy?
Well, you know that since it's a fraction, its domain is x. X cannot be equal to 2.
Okay, we know, just 2 though, right, Matthew?
Yeah. And asymptote for that too.
How do you know it's an asymptote? Why couldn't it be a whole?
Because
there's no removable discontinuity. The numerator can't reduce with the denominator. I'm stuck, right? But also, can't we think about how this is really just a transformed 1 over x function? Isn't it a transformed 1 over x? And isn't 1 over x a basic graph? And doesn't the basic graph of 1 over x, which is on the forever card that you should be memorizing? I'm pumping my arms and my feet really fast. Where is it? Oh, it's back here. This is a story. I have to like flip in the back side of that.
you have a little bit thing that shows it.
There he is. He's right here. It's in the bottom left-hand corner. Do you see him? Oh, just kidding. You shouldn't have to see him. You should have him memorized. Ooh, that's rough. So, what's 1 over x look like?
Something like this.
It's this. There it is, right? What's 1 over x squared look like? But 1 over x looks like this one, right? Okay, so what has happened to that parent function, that 1 over x? It's been moved to the right. It's been moved to the right 2, which we know because the vertical asymptote, right, is over here. And it's been a little bit stretched. Not shifted, so it still has a horizontal asymptote at 0. It's just instead of being quite so far away, it's closer in. It's the best way we can show it. We could talk about how it has a horizontal asymptote at 0 because the bottom wins, but technically that's section 1.6, so I guess we should be quiet about that. it, kiddos. What's the limit as, analyze the behavior of the function in the vertical asymptote. So we want to think about what's going on before the asymptote and what's going on after the asymptote, because every asymptote has a before and has an after. And what I mean by that is that to the left and to the right. True? Okay, so what's going on directly to the left of the asymptote? What's my function doing? It's going to, from below or from the left, it's going to negative infinity, aka, can we write this terminology real quick? Because the book has been using it a lot and it's not showing up on my phone. Okay. Another way of saying negative infinity, or the limit approaching negative infinity, is decreasing. Have you guys seen this yet? Decreasing without bound. You're going to be using that from time to time. It's decreasing without bound, so it's decreasing more and more and more and more.
Just keeps going.
Sure. Oh, you guys are cute. How about from the other side? Positive. So what's the terminology technically going to be? What's my function? Yeah, you got it. Just so you know what that is. Increasing without bound is approaching infinity, and decreasing without bound is approaching negative infinity. And we say approach because you can't get there. Sure. You can't get there. Yep. Okay, so if you have a graph, easy. Look at it and say, well, what's going on to the left of 2 and to the right of 2? Remember, I say below and above because I'm thinking numbers lower below 2 and numbers higher above 2. Not because I'm saying about where it is or where it's going. I'm just talking about the below, the to the left, and the above to the right. But what's going on this page? We're not talking about graphically. We're talking about numerically. Now, some of it got hidden because of my silly projector, and it doesn't quite fit on my smartboard and all that jazz. Oh, that didn't work. Take 2. Nope. Respond. Come on. Respond. Okay, now you can see it. How can we determine the behavior near the vertical asymptote without a graph? Well, let's use a table. So, calculators out. Let's just review how you use tables. Oh, I know. Big size. Oh my goodness, I'm making you use your calculator. The difference from last year. You can't use your calculators for all the tests. You shouldn't. But every now and then we should. Okay, so question. My discontinuity is 2. Yeah? And if I'm trying to figure out what's going on around 2, I should come from below, lower than, the left of 2, and above, higher than, right of 2. So we would do this as a 1.9, 1.99, 1.99. Do you guys still know how to do this? 2.001, 2.01, 2.0. Remember that you're going to your table. Remember that you're putting in your function to your y equals. Remember that you need your table set up to be on auto, not ask. Oh, nope. Ask, not auto. Thanks, Kathy. Ask and not auto. I'm curious if you can see a vertical asymptote in a table. I'm curious if you can see a vertical asymptote in a table. We can see it on a graph. Super.
If there's error, it's an asymptote.
Oh, but no. Error can be holes.
It can be asymptotes too.
I know, but you can't say an error is an asymptote. An error is an asymptote or a hole or an imaginary number, or error can be a lot of things.
If in the function they don't say like x does not equal to which value, that means it's not a hole.
If in the function it doesn't say x is not equal.
Yeah. If it says x does not equal.
Joe, there are lots of functions that don't say x is not equal and there are holes.
Yeah.
I can point to like 10 of them in homework tonight alone. So that doesn't work. But let's go ahead and plug in. No, I'm teaching. It's okay.
What the function looks like.
Okay, yes, I agree with you there. But that's you using your brain, not just seeing error and saying, must be asymptote. But in this one, yes. Because we can't reduce, but that's something that we see, not that the calculator tells us. So if you plug in 2, you would get error. Now, some of you are seeing 2 in your calculators because the calculator rounded. If you see a 2 with a value, you go up and put your cursor on that 2. I bet it's 1.999 or 2.0001. If you put in an actual 2, there will be an actual error number over 0. But what happens when you plug in 1.9?
Negative 30.
Negative 30. Did you guys get negative 300 next? And negative 3,000 after that?
Yeah. You just keep going to negative.
Do you see the vertical asymptote
Oh,
at the table?
this.
You see the vertical asymptote at the table? What's it doing? It's decreasing without bound as you get closer and closer and closer. So you get lower and lower and lower. Do you see it? A little delayed, but we'll take it. What if you come from the other direction? Guess what? It's 30 and it's 300 and it's... Do you see it increasing without bound? Do you see why we're able to? Well, why we're able to, we haven't even talked about it yet. Do we have to use a graph or a table to be able to do these?
Either.
Aren't we aiming towards not needing to use a graph or a table? AKA solve algebraically, AKA analytically. Now, what you can't say at the very top is, how do we determine behavior near a vertical asymptote without a graph or a table? It's impossible. Nah, that's just how you acted in pre-cal. How do you actually do it? Plug in a little bit below and a little bit above.
Can I interrupt for a second? Is it working or no?
I haven't tried to restart it, but you can.
Over here. Okay.
You can restart. Thank you. I saw your email too late, sorry. So how do we do without a graph or a table? We use our brains. Oh wait, we've been using them the whole time. Or we use them more.
You need a brain to use a calculator.
Hence why I just said we've been using them the whole time. But, coming back. How can we determine behavior near the vertical asymptote? Without a graph or a table. We plug in a little bit below and a little bit above. But for those of you that have been struggling with that terminology, can I say from the left and from the right? Is that okay? I think that's technically what the book uses too. The smart people that wrote the book. Hopefully they are. Otherwise we're in trouble. Gotta check the sign. Nice thing is we've done this before. I just did it a little bit early. Did you guys wonder why there weren't so many homework problems in section 1.2 with number over 0? Because our book had a whole section waiting. So, how do we analyze the behavior near the vertical asymptote? We come from below, and we come from above, and we say we don't need a graph and we don't need a table. All we need is oh, I just randomly changed it. That's not true. Now hold on. Didn't we just finish a homework that had an entire section that said find the limits, and we had weird from the right and from the left to find those limits? But did it change every single time how we solved the limit?
Yeah.
Wasn't one of them like 1 over 16? You just plugged in and you were done.
Yeah.
You didn't need to consider the above or below. It didn't matter. Plug in. There's an answer. You're done. Or you plugged in and it was 0 over 0. Keep going. You were supposed to factor and reduce and plug in. There was no extra step with the above or the below. There was nothing extra to consider. Just do it the old-fashioned way. But coming from the right and coming from the left are important when dealing with infinite limits or piecewises. And piecewises. So how do we know this is an infinite limit, guys? You should do what you should always do with a limit. And the very first thing would have been to, and when you plug in,
3 over 0.
Number over 0. Yes, 3 over 0, number over 0, which should point you in the direction of plus or minus infinity. Check the sign. True?
Yes.
Okay, so right away, I can put, and I don't necessarily like doing it, but I can put infinities. And I'm like, yay, the answer is infinity. But the question is, which infinity? I haven't finished my statement, Joe. The answer is infinity, but which infinity? True?
Negative
That's the question. But do you realize if you didn't know the answer automatically was infinity, you could go quite the wrong direction quite quickly, right? Both of these have an infinite limit because this is a vertical asymptote. I'm coming in, number over 0 is an indicator of that. All I need to do is check the sign. So yes, in this one it's important. I can't just plug in and be done. I can't factor and reduce and plug in and be done. I need to actually think about 1.9 or 1.9 or 1.9. What happens when you plug that in, guys? You get a positive over a negative, which is going to end up being which infinity?
Negative.
But if you plug in 2.1, 2.01, 2.01, So what's the behavior near the vertical asymptote? Well, of course you're going down. The math shows it. The function shows it. Of course you're going up. The math shows it. The function shows it. Did we need the graph? Nope. No. Did we need the table? Nope. Is it nice to have it? I think so. But did you have to have it? No. Now, if they were asking for the overall limit, they're just asking for the behavior. Hey, look, it's going down. Hey, look, it's going up. But if they were asking for the limit, how would you finish this problem? DNE, because the limits do not agree. Because the one-sided limits don't agree. Good, good, good.
Isn't do not agree DNA?
Careful. The limit does not. Oh, you're trying to get it. The limit does not exist because the one-sided limits do not agree. He's just because DNA. We can go back to chapel on Monday, Tuesday, but we'll just keep going. Chicken liver. Never mind. Don't want to know. Okay, so book open. Book open. You don't have to open your book, but let me open my book. Because, guys, at this point, can you check out the notes real fast? Do you see how I just have examples and then, hey, homework? So, excuse me, I'm choking on Mrs. Leon's pulled pork. So, not in a bad way, believe me. How should I choose examples? Why not just go to the homework and make sure we're good? Is that cool? So section 1.5. How many of you guys did that help when we were looking at section 1.4 homework? Cool. So section 1.5. Here we go. Homework starts off with numbers 1 through 4. Pause. If you come to me asking how to do a pink problem, what's the very first question I'm going to ask you? Did you watch the video of a teacher teaching it to you? And if you did, you can ask me a specific question about what you did not understand. But I shouldn't have to explain the pink ones, right? Okay, but hold on. We're just looking at categories. Categories. P.S. There's actually, I think, there's a CalcChat app where you can jump to a section and it's all stored in your phone. There's also a CalcView. Use CalcView app where you can just scan the QR code. It'll jump to the section and jump to the videos of each problem, just in case you're curious. But coming back. Section 1. What are you given? Okay, that's what you're supposed to do. What are you given? Graphs! I mean, functions and graphs. But yay, we have graphs, right? But the dilemma is, where are we approaching? Pause. Weren't you supposed to read this and summarize it before you read it?
Yes.
So what does the word say?
It says determine
Limit as x approaches -2 from the left and from the right.
Yeah.
Ooh, so we're doing a below limit and an above limit. True?
Yeah. True.
But we're allowed to look at the graphs and just use them?
Yes.
Nice. How about the next section? 5 through 8. What's going on? You're not given graphs anymore. What are you given?
Exercises.
Functions. You're given functions, but what do the directions say to do? Because there's no limit. I don't see a limit. I see a limit. Where is x going as x comes into 4 from below and from above? Do you guys realize that so far we're pretty much doing, remember section 1.4, the homework we're grading soon? Weren't the first few problems A, B, C, limit below, limit above, and then the overall limit? So what you doing? Okay. Now you're using a table, and you're approaching -3 for all of these dudes. Okay. Now it gets fun. What's going on up there? Directions. Say. Find what? Oh, just find the vertical asymptotes? Oh, how easy is this? Ready? Okay. There's a vertical asymptote of 2. There's a vertical asymptote of plus or minus 4. There's a vertical asymptote of plus or minus 3. There's a vertical asymptote at 3. We're done. And I was half wrong. Pause. Vertical asymptote at 2. Vertical asymptote at plus or minus 4. Vertical asymptote at plus or minus 3. Vertical asymptote at 3. I am half wrong.
There's 2. Oh, there's the question only asks like
Sorry, S instead of X. Which ones are right or which ones are wrong? The first one's right?
No.
First one's wrong?
Yes.
First one's right?
First
First
one's
one's wrong?
right.
Are you trying to
First
read
one's
me?
right.
Trying to read.
Second one's wrong. Like,
I think 16.
Okay, who has a reason as to why and which they think is wrong? Gavin.
16 is wrong because when you plug in plus or minus 3, it goes, but when it's squared, it becomes a positive.
The x
So-
Oh, and 9 plus 9 is 18?
9 plus 9 is 18.
Aw, lame. Oh, so maybe there are zeros. I said the wrong ones. So let's see. To solve the zeros, we've set equal to 0. Subtract the 9 and square root a negative number.
no.
Are there any zeros?
Imaginary numbers.
Imaginary numbers. So isn't this more like a none?
Yeah, you can use like 3i.
No imaginary numbers in calc.
Oh,
At least
okay.
not right now. Just kidding. Not at all this year. Sam, what else is wrong?
Number 20.
It's wrong,
Yeah.
but it's a
How is
zero.
that wrong?
Look,
It's a whole.
Oh.
It's a whole. How do you know?
Because you can factor the top.
Smarty pants. Can you guys factor the top? I'm not so sure about that. But another way of looking at it, he's right. You can factor the top. But another way of looking at it, listen to Tyler, is what?
You just get 0 over 0.
And what's 0 over 0 always an indicator of? Keep going, aka a whole, aka it can be removed. It can be removed by factoring. Now, how many of you guys have memorized that the numerator is x minus 2 times x squared minus, no wait, same, opposite, always positive?
Plus b minus.
Or you can.
Because the difference of cubes has like a memorizing thing as to how you get there. But most of us don't know how to do that.
Just use
Okay, plugging in. You see the 0 over 0. I get it. But I'm worried this is going to show up as a limit problem. You're going to need to keep going, and you're going to be like,
Yeah, I was just
So-
saying. I took what Sam did.
maybe the other way is you can do it this way. 1, 0.
Oh no.
Oh! You can bring it, you can bring it, you can bring it, you can bring it, you can bring it.
Ew, no, I don't like that. It's
Done.
Hey, look!
That's like
This could become x squared plus 2x plus. Anyway, long story short, that's not what we're actually doing. I know. But was I right by saying vertical asymptote? No, because Sam, what is it instead?
a whole.
It's a whole. But am I right on this one?
No,
I am right on that one, but why?
because the square is outside of the.
Both of them make zeros, and each of them are going to be a number over 0. Have you guys checked it?
Yeah, 8. Wait,
S
I
plus
was
4
18.
and S
Oh.
minus 4, neither of them will reduce. So both of them are non-removable, aka vertical asymptotes. If you were to plug in positive 4, number over 0, negative 4, number over 0, booyah. So are these easy? Yes, but could you get
Minus
tricked?
60.
Yeah,
Ah,
absolutely.
be careful. All right, as you guys are pondering, I'm going to come back and check in with Mr. Crowell, but can you guys read the directions on the next section? And ponder what you would do on 33 to 36.
Pretty sure 33 is back to x squared minus 1 is x. Okay, so 33 is
Exactly.
This works better.
Still slow. I don't know what's going on.
Better than what?
Wait, what are you doing? I'm doing 0 to 0. What are the directions?
To determine whether the graph of the function is a vertical asymptote or a whole.
And what did we talk about from up here that's going to help us with that Tyler was saying? Is it a keep going? Is it a 0 over 0? Or is it a not keep going? Is it a number over 0? Plus or minus infinity check the sign, right? So I hear you being like, ooh, woohoo. I hope I gave you that one. All right, what's going on in the bottom section? Because it has an ln. Everybody gets scared about an ln. I need you to be scared now rather than scared on the AP.
What did we do?
I guess
What's going on in the bottom section?
What did you get scared on the?
Finding a one-sided limit.
Finding a one-sided limit.
Meaning you can only.
So wait a minute, what about this one-sided limit? Oh, it's going to be so hard, I can't even factor, and if I do, it's
A
imaginary
squared
numbers.
Wait, is that 5? No, that's 4.
How do we do the one-sided limit of this one? 1.9? Can means you're only coming from, you see them, they're really small. You're only coming from one side. That's a plus, that's a minus, that's a plus, that's a minus. She's like her glasses. It only has like one of the directions. Okay. Guys, is this a really, what would you say for this one right now? Positive infinity. Is it a positive over a positive? Dun, dun, dun.
No.
It was never number over zero.
Yeah.
Isn't this one of these just plug
squares
in and it's an answer?
always zero
Oh my
or
God.
positive.
This is going to be 4 over 8. It's 1 half.
Yeah.
So are you plugging in 1.999 every time?
No.
I mean, if you're doing 2 below. No, you have to check first. Now, if it's number over 0, negative 1 over 0,
This one
should
does
you
have
go looking for check the sign? It's an infinity.
Yes.
But you have to check first that it actually fits the number over 0 pattern. Does that make sense? Is it pretty awesome that the homework isn't just giving you the same old type of problem over and over and over again?
Yes.
Because what does the test give you? So you have to be ready. Is it a number over 0? Is it a 0 over 0? Is it just a plug in and you're done? But homework helps you practice. All right. So that's what's going on here. Can we go ahead and get to our flip book since I have my webcam already ready? Flip books. Yeah. We're done.
Sorry.
It's like a robotic cat. Anyway. Meow. Oh, is that funny? Okay, sorry, that's not what she meant. So, limits analytically, our flip book. This is not zooming in or out. What the? Oh well, that's okay. Finding limits analytically. Okay, what can we fill in that we have not yet already? Boop, basic rules, already filled in. Let's see, those are nice little basic rules. Talked about those already. Wait a minute. Have we even done this yet? Oh, I have marker on my hand. Have we done limits at infinity? Oh, that's weird. I wonder if it's coming. Oh, look! Section 1.6. It's coming. So don't worry. We'll come back to that when... Oh, but have we done the special limits yet? Answer is yes. We have done the special limits because we have a forever card, don't we? Like, isn't it kind of important? Now, quick word to the wise. Online, I have your forever cards all up to date because we do have that forever quiz coming. You do need to update your cards, etc., etc. But on the one online, I actually have 4 special limits because CalcBC brings in another one. So there's actually a 4th one, but you guys don't need to worry about the 4th one right now. Does that make sense? Just the ones that you wrote in the notes, just the ones that we have here. Got it. Test is Thursday, Tuesday or Wednesday? Wednesday. We need it before the test, so that way you have it down before the test. We could do it Wednesday, but then you won't know what you got right or wrong. I mean, you will. Yeah, we could do it Wednesday. We'll see. Okay, did we already figure out this one? How we had to, let's see. Oh, here was just to plug it in. Oh, that's annoying. I want to use whiteout, but then I have whiteout on the orange paper. Anyway. This one, 0 over 0, keep going. We already did that one too, right?
Yes.
Sweet. This one, did we multiply by the conjugate? Actually, did we? I feel like we didn't in this class. Did we actually do the conjugate?
Yeah, we did.
We did? Perfect. You're taping it and gluing it in your notes for a nice little flip book. Because see, there's a space for glue or tape right here. Oh, right here above the dotted line. If you put glue stick right there, then you can glue it and then you can still access like your last page. I mean, it's technically like this. So you'd be able to do like that. Sorry, where were we? Ray did that. Thanks, Rana. And Salma and whoever else is helping me. How about this one? How about the tricky one? No, we did not do this one yet. The tricky one, but hold on. Have we done tricky stuff? Yeah, we have. Tricky ones! Can we get 0 over 0s with trig? Yeah, we can. Now on this side, do you guys see what they did in the example? Check out yours. You have it solved. Do you see where they multiplied by the conjugate? Why did they multiply by the conjugate? Oh, because 1 minus cosine squared is sine squared. It made all the difference. But what are we going to do on this one? Now, sadly, I already did it in period 1, so that's kind of rough. Do you guys see how cosine x minus 1? Man, if that was over x, that would sure look an awful lot like my special trig limit, right? I want an over x for that guy, and I want an over x for that guy. But I don't have it. So what can I do if I don't have it but I want it? Ooh. Now I'm not simplifying a complex fraction, but I am allowed to multiply by 1 creatively whenever the heck I want. So I can go ahead and multiply the top by 1 over x and the bottom by 1 over x, and I'm like, I'm on my way to special trig limit. Except, isn't the order a little bit off of here? Shouldn't it be 1 minus cosine? So I factor out a -1 because you can do that in math. I factor out a -1, that way I have my 1 minus cosine x all over x, and then on the bottom I have a sine of x all over x, and I'm doing all this work because I tried to plug in. I knew my unit circle. Struggle, some of you, that was at you. And I knew it was 0 over 0, keep going. Okay, so I'm doing all this work, trying to make it look like special trig limits. Hey, it does. According to the properties in the beginning of your rule book, there's a fly on the side. According to the properties or the basic rules at the very first page of your rule book, am I allowed to do a limit of a top and a limit of a bottom to solve a limit of a quotient?
Yes.
Yeah, we could look, and I could show, and be like, hey, as long as the bottom doesn't equal 0. Wait a minute. No, that was the whole problem. The bottom does equal 0. Not anymore. What does sine of x over x go to, guys? Ooh, it goes to 1. And 1 minus cosine of x over x goes to 0. Wait, -0 is still just 0. So what's 0 over anything? Some of you would say undefined, and you are horribly wrong. Wrong way. 0 can't be in the bottom, but he can be in the top. 0 divided by anything besides 0 is 0. Dun, 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 dun.
So it's only undefined when 0's on the bottom? Doesn't anything divided by 0 just 0? No, wouldn't it be that?
Because of division. 4 divided by 8 is 2, right? Because
4 divided by 8 is 2.
1/2. 40.
I think you're right.
You guys trust me way too much. 4 divided by 8 is 1/2. Why? Because 8 times 1/2 is 4. Every division problem and answer gives me a corresponding multiplication problem. So 0 divided by 1 is 0 because 1 times 0 is 0. I can always get anything to have a 0 on top because it's just times 0. But if it's the other way, 1 over 0 is, does 0 times anything equal 1?
No.
Impossible. Undefined. That one's 0. That one's 0. Coming back. Not imaginary. No. Just D&E. Okay, hold on. The next page. Let's fill it out. No. What does it say? At infinity. That's section 1.6. But what's on the very back of your flip book? A piecewise function. A piecewise function. I'm trying to cover up. Where's my... There we go. Okay. Piecewise functions. How do we take a limit towards a piecewise? We have to come from below and above because we have a piece below and a piece above, right? So how do we go to -3? Well, we need to go below -3 from the left of -3, which would be plugging into that piece, right? Ta-da. And then we come from above -3, which would be the greater than or equal to from the right of -3, which is that piece. Ta-da! And when they both equal the exact same 3 thing, you're welcome. We know the limit exists, and the limit is 15, but why did I make a big box around this one? It wasn't a box, but whatever. Why did I highlight it? It's saying if they didn't agree, what would happen? The limit would not exist. Now, over here, how do I get the limit as x approaches -2 of g of x? Come from below and above, of course, but pause. This morning I went ahead and said, okay, hold on. What if this wasn't the question? What if the question was the limit as x approaches 3 of g of x? Why did I write -6 and didn't show any other work? What if you weren't
Because you
approaching
plugged in 3 to the bottom.
Why did I plug in 3 to the bottom one?
3 is greater than...
Because 2.9 is here and 3.1 is here. Everything around 3 is all right here. All I had to do was plug it in, because the function is continuous around 3. not even a possibility of being discontinuous, so I can just say, whatever. The above and below 3 are both here. Plug it in, plug it in. 3 minus, what's 3 times 3 again? Equals negative 6. You're welcome. But if I'm approaching negative 2, where's the below and above negative 2? Right? So we have to plug in below and plug in above. And then we end up with an agreeing limit of 9. Both sides agree. When you plug in negative 2 to the top, you get 9. When you plug in negative 2 to the bottom, you get 9. So therefore the limit is 9. But if they didn't agree, the limit would not exist. Okay, homework open. We're going to grade the evens real fast. Nice thing is, period 1 got to grade, but no questions. You guys will be the same, but I think I set you up for knowing what to do in section 1.5, yeah? I thought so. So let's grade 1.4, and then tonight you can look over any evens that you missed as you do, well not as you do, then do section 1.5. Come tomorrow with all kinds of homework questions, which is another good reason that we're taking 2 days on 1.6 and not just 1. We can spend some extra time on homework questions tomorrow. Here we go, guys. This will be in the video, so if it's too fast for you to grade, you can go online and grade from the video and pause it at any point. Number 4. All of them are 3, 3, 3, and the function is continuous at negative 3. A, B, and C are all 3, and the function is not, my bad, is not continuous because the point, the limit's fine, but the point is somewhere else. Number 4 is discontinuous. The limit's fine, 3, 3, 3, but the point is somewhere else. Number 18, they do not agree. The one-sided limits do not agree, so the limit does not exist. Number 18, nope, it's DNE. They did not agree. Number 32, discontinuity at 1 because the limit did not agree with the value. The limit did not agree with the value. Number 38, there is a non-removable discontinuity because, obvious, number over 0. But the way the book describes this is whether or not the limit exists. No!
Hey Warriors, it's your old pal Jake. Sorry for the interruption, but tomorrow there will be a fundraiser for your senior student council. There will be selling Krispy Kreme donuts in front of the gym before school and during high school and middle school nutrition tomorrow.
If there are still donuts during high school nutrition.
Go Warriors.
No guarantees. Sometimes there is, sometimes there's not. Number 48 has a non-removable at 3 and a removable at negative 2. If you guys canceled out and didn't write it down, by reducing, I shouldn't have said canceling, by reducing, it is a removable discontinuity. Don't forget about those guys. For number 54, the limit does not exist, so therefore there's a discontinuity at 2. Number 66, A equals 4. And number 102, intermediate value theorem. The theorem did apply, and C was 3. IVT did apply. Wait, let's do it out. Come with section 1.5, hopefully indented at 1.4 questions. Sound good?
Yes.
Yeah,
Happy Thursday on
You guys go to that hydro, right? Someone left it this morning. The teal one.
Oh, that might be Abby.
Oh, that might be one.
Actually, I have no idea.
I
Tell based off of the. Actually, that might be
at the office as a fangirl.
This is do you know why you mistakenly write 4 divided by 8 as